Let us now discuss the laws of radicals. So the first one is quantity nth root of a raised to n, and that is equal to a. Now, if and only if your n, which is the index, is odd numbers. Okay, odd numbers are 1, 3, 5, 7, and so on. Now, let's have an example. We have here a quantity of nth root of 5 raised to 3. So you can simply write it as cube root of 5 raised to 3 to erase the confusion. Okay? And since our index and our exponent are the same, you can now cancel it. And the answer is 5. Okay? Now you see our base is 5 and also our answer is 5. Another one, we have a quantity of cube root of negative 5 cube, and you can simply write it as a cube root of negative 5 uh, cube. Now, we can now cancel it, and the answer is negative 5. So, the negative sign will not be affected with the index, since our index is odd numbers. Odd number, which is 3. So, what happened if our index is even number? Or even numbers? Okay, so we have here if our index is even numbers, what are the even numbers? That is 2, 4, 6, 8, and so on. The answer is in absolute number. For example, we have quantity of 6 root of 7 raised to 6, or simply write it as 6 root of 7 raised to the power of 6, then cancelled it. So your answer is in absolute number of 7, which is 7. Okay, so when we say absolute number, the answer is always in positive. Okay, positive number. Next, number 2 is quantity of 6 root of negative 7 raised to the power of 6. Or you can simply write it 6 root of negative 7 to the power of 6. Now, since our index and exponent are the same, you can now cancel it. And your answer is in absolute number, which is absolute of number of 7. So the final answer is in positive 7. So that is the difference when your index is odd number and your index is even number. Alright? Let's go now to the next law of radical, which is nth root of a and b. So we have nth root of a multiplied by nth root of b. So example, we have square root of 18. Now, as you notice, 18 is not a perfect square root. Okay, now what are we going to do is to find the factors of 18. The first one is a perfect square root and the other one is non-perfect square root. So if you see, okay, these are the perfect square root 1 to 5. We have 1, 4, 9, 16, 25. So 9 is a factor of 18. So you can use 9 and 2. Okay, so you can write it as square root of 9 multiplied by square root of 2 is also the same with square root of 18. That because 9 times 2 is 18. Then square root of 9 is 3. So you can simply write it as in simplified form. We have here 3, then square root of 2, and that is the final answer. Another example is the cube root of 81, and as you know, there is no perfect cube root of 81. So we will get the two factors where the first one is the perfect cube root and the other one is perfect cube root. So here, 27 is a factor of 81. So we can use 87, which is 3 cubed. So 27 times 3. Okay, so you can simply write it as cube root of 81 is equal to cube root of 27 times cube root of 3. Okay, and in simplified form, cube root of 27 is 3. So you can write it as 3 cube root of 3. And that is the final answer. Let's go on now to the last example. We have here cube root of 24, x raised to 5, y raised to 7. Now, let's find first the factor of 24, which is get the perfect cube root and non-perfect cube root, which are 8, cube root of 8, and cube root of 3. Now, write these two numbers in this area. Okay, so we have cube root of 8 and cube root of 3, which are the factor of cube root of 24. Now, in x, we have x raised to 5. Our exponent is 5, and our index is 3. So, get the value of 3 into 5, and the difference will be put on the other side. Next is, in y raised to 7, get the uh, values of 3's in 7, so that is 6 and the difference is 1. Put that again in the other side. Then your 8, okay, will become 2 cubed. Okay, so we can cancel it. Okay, so your 6 will become 2, and your final answer will become 2xy squared. Then copy cube root of 3x squared y. Another loss of radicals is nth root of a over b. So it will become nth root of a for the numerator over nth root of b for the denominator, and b is greater than 0. So example, we have cube root of 125 over x raised to 12. So our you can write it as cube root of 125 over cube root of x raised to 12. So our cube root of 125, we can simply write it as uh, uh, 5 cube. So we have cube root of 5 cube over cube root of the factor of 12 is 4 and 3. So write it cube quantity x raised to 4 and 3. So we can cancel this part. And your final answer is 5 over x raised to 4. Let's go on now to the last laws of radicals, which is nth root and nth root of a is equal to n times nth root of a and vice versa. We have here 6 root of 25. Now, the first step is we will factor 6. It's either, of course, 2 and 3 or 3 and 2. But that is depend on the on its base, which is 25, and 25 is also equal to 5 raised to 2. So since your exponent in your base is 2, okay, the inner radical is squared and the outer radical must be cubed. Okay, why? So we can cancel this part. So your final answer will become cube root of 5. Last example is we have cube root and square root of 27. Now, 27 is equal to 3 cubed. So, um, what are we going to do with the radical? We will interchange it. The squared will be go outside, and the cube root will be in the inner part. So, because 27 is equal to a cube root, and so we can cancel this part. So your final answer is square root of 3.